Great morning. Talking to you guys. Couldn't get any better. Okay, let's start with today's episode. Hello, guys. My name is Reza, and welcome to my C programming series. This episode, I'm going to talk about pointers. Pointers are the most important topic in C programming. If you nail this, you would nail C programming. You would be an amazing programmer, and I will help you how to master it. Pointers are important, but they're simple. Computers deal with memory. Any application that you run, every software that you run, every block of code that you execute, every instruction that you execute, every variable, all of them have to be stored somewhere in the memory and then sent to CPU for execution. So as programmers, we need to know memory very well and know how to work with it and how to manage it. If I want to tell you what is pointers in only one sentence, I would say pointers are integers, numbers that stores the memory address of a variable. Imagine the example I usually make, the addresses. Imagine a street that there are different buildings in it. And you have a paper, and in that paper you wrote the address of that, for example, unit number 13 in that street. If I look at that paper, that's actually the pointer to that building. The pointer is an integer that holds the address of a variable in the memory. Basically the same thing. When we write our programs, what we do is basically reading from the memory or writing to the memory. So knowing the address of our variables in the memory can help us a lot, and I'll show you. You might say we were doing it without knowing pointers, but yes, you're right. But you can write C applications without using pointers. But with pointers, sky's the limit, and you can do anything with C programming. Pointers are such an important topic in C programming, and I have to emphasize that a lot. And we will use pointers a lot when we are dealing with blocks of memory, like arrays. Don't forget, pointers are just integers which store the address of variables of any type, no matter the type, double, float, or a string, or any other type. The pointer to that variable is an integer. Let's work on some examples. Let's create a basic pointer, for instance, void star. Remember, void means no type? Go watch the function video if you are not sure what the void keyword is. So I create void star var1 equal to 0. In this line of code, we're creating a memory address of no type, and we're storing 0 in it. However, memory addresses does not go all the way to 0. This means that we have not initialized this pointer. This pointer does not point to any memory address. We have a keyword in C for it called null, all uppercase. And look, when I hover my mouse on null, it says that it's just a compiler constant. It's just hash define null, which is void star 0. It means that this pointer has not been initialized. It does not point to any memory address in the whole memory. Let's do something useful with it. I'll create an integer called var1. Let me get rid of this. And set it equal to 8. Every variable we create has a memory address because we want to store it somewhere. Now I want to store the address of the integer we just create to a variable called ptr. So void star ptr equals to and percent var1. Remember the ampersand we use to return the address of a variable? We used it in scanf function. Pointer is an address. It's in right hand side, and the left hand side should also be address. That's why we use ampersand var1. Now both sides of the assignment operator off at the same time. Both are addresses. If I put a breaking point on line 7 and debug the code, you would see that the value of var1 is 8, as we specified an integer, and the value of pointer is like an hexadecimal value, which is the address of the variable var1. Let me prove that. This is the address of var1. Let me right click on it, copy it. I'll go to debug, Windows, memory, and then I'll choose the memory module 1. And this is my memory layout. All the variables has been stored into memory. If I right click here and click paste and get rid of void star and the space here and get rid of PTR here. If I click enter, I'll be forwarded to this memory space. And as you can see, it's pointing to an integer 8, which is exactly what we want. We want the pointer PTR, which we just copied the address from, to point to the variable 1 here. Variable 1, the value of variable 1 is 8. So this pointer is pointing to this variable in the address, pointing to the address of this variable in the memory. And as you can see, the value of this variable var1 is 8. We set the pointer PTR to be void, but it doesn't matter in this case. If I change it to integer and restart debugging the code, you see the code is working and there is no problem. Let's get out of debugging mode. Remove the breaking point. The only reason I would keep the type the same as the variable is in this case the variable 1 is integer. So I changed the pointer to integer. So now the pointer is pointing to an address, which in that address an integer is stored. Be careful that int star is something else. It's not like int that I just added in a star to it. It's a different data type. So just int star means that this address that is stored in PTR is pointing to a memory address that an integer has been stored in. So this way, I'm telling the C compiler that I know which variable this address is pointing to. And if I wanted to manipulate the data, change the data using the address, using the pointer, C would allow me to do so. But if it was void and I wanted to modify the number, it wouldn't allow me because it don't know what is this memory pointing to. Is it a double? Is it a constant? Is it a, what is it? Okay, let's experiment this idea. Here's an example we were working on. Consider I want to change the value of var1 using PTR. I'll just put an asterisk before PTR. So this is called dereferencing. What I'm doing here now, by putting in a star before PTR, I'm accessing the value that is stored in the address PTR. They call it dereferencing. I can say it's equal to 10. Let me put a breaking point here and start debugging the code. Okay, let me actually put a breaking point here. I want to go line by line. We start debugging. Okay, here you would see that we have an address which is uninitialized, and we have a var1 which is uninitialized because we haven't executed line 5 yet. If I step over, var1 is 8. If I step over, the address will be stored in PTR. And now the fun part is line 7. We will dereference the address, which means that we are pointing to the address where this 8 is reserved, and then we'll change that 8 to 10. And you see, var1 is now 10. We knew where var1 is saved and went to that address in the memory and changed the value. To do that, we needed to dereference the address by putting just an asterisk before PTR. But see, if this int was void, and let me restart debugging, we'll see an error here. The error says expression must be a modifiable L value. It means that you cannot put 10 into asterisk PTR, and the reason is I don't know what is it to put 10 in it. I don't know if it's void, I don't know if it's double, I don't know if it's integer. So we need to tell the C compiler that what is the type of the variable that we are pointing to, and in this case it's integer. Thank you for watching this video. I'm so happy we are getting to the fun stuff in C programming. The series is just getting started and I love it. Let's smash the like button, subscribe the channel if you enjoyed the video, and we'll see you in the next episode.